Let me keep them separately, or if you like, you can write PL mu square. Similarly, 1/2 beta 0 square would be alpha prime by 4 P R mu P R mu. Correct? Now, and we know that this should be we use the mass cell condition. Mass cell condition would give me this PL square equal to mass square. So m square is PL mu of P mu in general, and for this you can say PL mu. It would be same also minus because of our metric. Okay, we have a metric with the signature -1 +1 +1 +1, and so this is the mass cell condition there. Okay, and similarly this would be minus n square. This is what am I doing? So 1/2 alpha 0 square this is only one term. I should not make blunders. This would also be alpha prime by 4 into minus m square. And now we carefully want to make use of these relations here. And we keep in mind that in these expressions that I have just erased, mu is being summed up on all the dimensions from 0 to 25. And now we want to consider a case where we want to compactify the x25 dimension. We now want to consider the compactification of one of the spatial dimensions, let us say along the 25, x25. Okay, and as a result of that, what would happen here, that what we wrote here and for here, this would change, and that would change the mass spectrum, because what are we going to have is in the first place, let me explain to you the idea of compactification, and let us consider only closed string. So what happens is we consider only closed string and we consider compactification. Okay. Of x25. Let us consider compactification of x25 dimension. Okay, of x25 dimension. So for a closed string theory, x mu of sigma plus twice pi tau is x mu sigma and tau. This is for a non-compactified dimension. Now, what we want to do for x25, what we want to do is x25 sigma plus twice pi tau. We define it to be x25 sigma and tau plus twice pi n. What we want to do is we want to consider the compactification of the 25th dimension. So here we have x25. Now, in general, this holds true for all the non-compactified dimensions. Okay? And this is for the compactified dimensions. So we want to compactify the 25th dimension along a circle of radius r. We want to compactify the 25th dimension along a circle of radius given by capital R, and here n would be the binding number. Okay, so we introduce a binding number, and we introduce another variable w, which is defined to be nr by alpha prime, and r by alpha prime. And so this nr, this term, this could be plus twice pi alpha prime w. So this could be written as this or that. So essentially we have only introduced this nr by alpha prime, a new variable given by w. And now I would need these relations a little bit later, but before that, let me as we have earlier done, namely we splitted our x mu into the as a sum of two left moving and right moving waves. We do it for x25. So we put mu equal to 25 in our general expression. So what you have is x25 L sigma plus, this is 1/2 x25 plus 1/2 alpha prime tau plus sigma, tau plus sigma, PL25 plus iota alpha prime by 2 summation over n alpha. For left we are using alpha, right? For right we are using beta. So alpha mu is now 25 alpha n divided by n e to the power minus I n sigma plus. Okay, and you have x25r, this is 1/2 x r 25 plus alpha prime by 2 tau minus sigma P25r plus iota alpha prime by 2 summation over n beta n 25 e to the power minus I n. This is taking too much space, so let me remove them for the time being. We don't need them. So beta sigma minus. Okay, and from that what we do is we want to write down x25, which would be, we want to sum these two. So what you have is 1/2 of this plus 1/2 of this. If you assume this equal to this, so you, or x25 plus alpha prime by 2 into tau into PL25 plus PR25 plus alpha prime by 2 into sigma into PL25 minus PR25 plus the modes. What we have done is, we have just summed up these two left moving and right moving modes along the 25th spatial dimension x25, and what we have obtained is the following. Now, because whatever we have learned for the non-compactified dimensions, that was true for non-compactified dimensions. For example, P25 for a non-compactified dimension would be continuous momentum. P25 is a center of mass momentum of the string. X25 is the center of mass coordinate of the string. Okay, along the 25th dimension right now. But when we compactify a particular dimension, as we have done now, as we are doing right now, that we have imposed different conditions on X25. Therefore, we have got these two things separated out. This is called as the momentum mode, and this is called as the binding mode. And so we have to see what